Today, we're diving into the massive leap AI is taking right now, moving from simple chatbots to truly powerful active agents. We're going to see how we get from a lonely brain in a jar to a real digital assistant.
You know that feeling, right? You have a fantastic conversation with an AI, you teach it something new, and the next day it has total amnesia. Or you ask it to do something simple, and it's just stuck. It's a super common frustration, and there's a very specific reason for it.
And this really gets to the heart of the problem. A standard large language model, an LLM, is basically a brilliant brain in a jar. It's incredibly smart, sure, but it's completely isolated. It can think, it can write, but it can't actually do anything in the world or even remember what you talked about yesterday. It's a brain without a body.
So in this explainer, we're going to pull back the curtain on how developers are giving these brilliant brains a body, transforming them from these passive text predictors into active problem-solving agents.
All right, so let's start with the jar itself. What are the actual limitations that are keeping this brilliant brain all boxed up?
Well, it really all boils down to one word: stateless. An LLM's entire universe of reasoning is stuck inside its context window for just one single chat. You can think of that as its short-term attention span. If information isn't in that window, then for the model, it might as well not exist at all.
And that statelessness leads to two huge roadblocks. First, without a connection to the outside world, it can't do things like check a flight status, search the web for you, or book a meeting. Second, because it's stateless, the second your conversation is over, poof, that context window is gone. It has zero long-term memory.
So how do we solve this? Well, it's pretty straightforward, conceptually. We give the brain a body. We build a complete system around the model, turning it into what we call an AI agent.
Now, what's really cool about this is how it basically mirrors a living thing. You've got the model, the LLM, which is the brain doing all the thinking. Then you give it tools. These are its hands. These are just APIs that let it do stuff like search the web, pull from a database, or send an email. And finally, you have the orchestration layer, which is like the nervous system connecting the brain to the hands and managing the whole show.
And this perfectly captures the new paradigm. See, an agent isn't just a one-and-done call to a model. It's a whole system that uses that model in a continuous loop, calling on its tools whenever it needs them until it actually achieves the goal you gave it.
This loop, think, act, observe, is the agent's core problem-solving engine. So let's say you ask it to find the score of last night's game. First, it thinks, okay, I need real-time info for that. Then, it acts. It calls a web search tool. Then it observes. It gets the score back from the search. Then, the loop starts again so it can think about the best way to give you that answer.
Okay, so an agent can act. That's a huge step. But what about that memory problem? Let's start with short-term memory, which we can manage on something you can think of as the agent's workbench.
The source material uses this fantastic analogy, and it's perfect. A session is like a temporary workbench where the agent is doing its work for one specific conversation. All the notes, the chat history, the results from its tools, it's all laid out on this workbench, right where the agent can see it.
So, technically speaking, a session is the container for all that conversation history, plus what's called its scratchpad. That's the temporary notes the agent makes while it's thinking through a problem. It's the thing that lets an agent remember what you said 5 minutes ago in the same chat.
And this, of course, leads to the next big problem. What happens when the conversation goes on, and that workbench just gets more and more cluttered? Well, a cluttered workbench leads to some pretty serious issues.
Yeah, as that workbench gets piled higher and higher with chat history, you start to run into trouble. You'll eventually hit the model's context window limit, but even before that, you're paying more for every API call, the responses get slower, and the model's performance can actually get worse. That's a phenomenon called context rot, where it kind of struggles to find the important bits in all the noise.
So, to solve that messy workbench problem and to get to true long-term memory, we need a much better system for organization. We need a filing cabinet.
And the key insight here is that you don't just shove the whole messy workbench into a closet. No, that's not helpful. You go through it. You pull out the most important facts and insights, and you file them away neatly. In the world of AI agents, this organized system is called memory.
This comparison here on the slide makes the difference crystal clear. A session is the temporary workbench for the now. Memory is the persistent filing cabinet that builds long-term knowledge across all of your conversations.
It's how an agent can remember your preferences from a chat you had last week. Now, it's really important not to confuse memory with another common AI technique called RAG, or Retrieval Augmented Generation. This table does a brilliant job of showing the difference. RAG is like a research librarian. Its job is to inject factual knowledge from static documents like PDFs. Memory is like a personal assistant. Its job is to learn from your dynamic conversations to create a personalized, stateful experience. A truly great agent, by the way, needs both. So now that we have all the core pieces, the body, the workbench, and the filing cabinet, we can start to look at how these agents are evolving from simple tools into some really sophisticated systems.
This quote from the source material just perfectly captures the shift. We're moving beyond just playing with models and into building actual, useful software applications that are powered by these models.
And we're already seeing this evolution happen across a few distinct levels. Level 1 is that basic agent we've been talking about. It uses a tool to solve one problem. At level 2, the agent becomes more of a strategist, breaking down a complex goal into a multi-step plan. And then at level 3, we get to the really exciting stuff. A whole team of specialized agents working together, with a manager agent delegating tasks to, say, a marketing agent or a coding agent.
Okay, so building these powerful systems is one thing, but deploying them safely and reliably out in the real world, well, that presents a whole new set of challenges.
The big takeaway here is that as these agents become more autonomous, the risks definitely go up. We need whole new disciplines like agent ops just to handle their unpredictable behavior. We need serious security to stop them from being hijacked through things like prompt injection. And as companies start creating hundreds of these specialized agents, we need good governance to avoid what's called agent sprawl, a chaotic, unmanaged mess, and of course, to protect user privacy.
And so this is the really big question we're left with. We are rapidly moving from just typing a prompt into an AI to collaborating with a team of capable, persistent, and increasingly autonomous agents. The question isn't just what can AI do anymore, it's what can we achieve together? And that is a fundamental shift in how we're all going to work, create, and solve problems in the very near future.